Recording in progress.
Good evening. Good
Good
evening.
evening, teacher.
Good evening, teacher.
Good evening.
Good evening, madam.
Hari. So we were discussing about the composition of mixtures, right? Expressing the composition of mixtures. Can you all turn on the videos, please? Hari. So we discussed about how many methods? M over M, then V over V, then what else? තමනාද කිව්වේ? කියන්න බලන්න. What are the methods of expressing the composition of a mixture? Did I give these two for homework? Or else did we do them in the class?
We did it in the class.
Okay. So we had to start the fourth method. So we discussed M over M, V over V, then mass over volume, M over V, right? These methods we have discussed. So today we are going to learn the fourth method of expressing the composition of a mixture. Expressing the composition of a mixture in terms of number of moles divided by the volume, right? Which we call as the concentration later on. Hari. So this is used to express the composition of a homogeneous mixture. Liquid homogeneous mixture. So what do you call them? Yes? Solutions.
Solution.
Yes, solutions. Hari. So here it says mole is the international unit for the amount of substance. Mole is the SI unit for the amount of substance, right? Hari. The composition is given in terms of the amount of moles of solute contained in unit volume of a solution. Then make a liquid homogeneous වෙන්නත් පුළුවන් නැත්නම් we can say solid liquid homogeneous mixture like a salt solution, copper sulfate solution, potassium permanganate solution, right? For those also we can express the composition by means of N over V. The composition expressed in this way is called the concentration. This is what we call as the concentration. So the concentration is equal to C equals N over V. In chemistry, very often concentration of a solution is expressed in terms of the amount of moles of solute contained in a cubic decimeter. ගොඩක් වෙලාවට දැන් අපි we can say C equals concentration equals number of moles divided by volume, right? Concentration equals number of moles divided by volume. So you know the SI unit of the number of moles is mole. The amount of substance is measured in moles. ඊට පස්සේ the volume SI unit is cubic meter. But in chemistry very often concentration is expressed in terms of moles per cubic decimeter. මතකද අපි ගිය සතියේත් කිව්වා M over V even we express it as grams per cubic decimeter, though it is not the SI unit, right? Most frequently we use the unit as grams per cubic decimeter in that case. Here volume we take in volume we take in cubic decimeters, right? We take it in cubic decimeters, dm3. Therefore the unit becomes moles per cubic decimeter. Moles per cubic decimeter becomes the unit. This is not the SI unit, right? So we can mention the SI unit. SI unit is moles divided by cubic meter. So it is moles per cubic meter, right? That is the SI unit, but most probably in our calculations we use moles per cubic decimeter. So you can write this even in words. Concentration equals number of moles divided by the volume. Hari, you can write down. So it's easy. You can write it even in words. Concentration equals number of moles divided by number of moles divided by volume. this is what we have written in symbols. C equals N over V. C equals N over V. So the unit becomes moles per cubic decimeter. Yes, Tejan, Nelly, Meena. Right, then do the next calculation. Next means the first calculation based on that type. Hari. Yes. Kian Balan. Okay. 2 cubic decimeters of a solution contains 4 moles of sodium hydroxide. Find the sodium hydroxide concentration of this solution. So you can write the equation in words or by using the symbol. C equals N over V. Number of moles equals 4 moles. 4 moles. And the volume is given as 2 cubic decimeters. 2 cubic decimeters. Therefore, 4 divided by 2 means that is 2 moles per cubic decimeter. එතකොට මේක මේ විදිහටම ලේසියටම දෙන්නේ නැහැ. ඒ කියන්නේ මෙච්චර ලේසි එකක් නෙවෙයි. They combine this with molar calculations. You are supposed to you are given the mass of the solute and you are asked to calculate the concentration. එතකොට තව පොඩි step එකක් තමයි add වෙන්නේ. මොකක්ද? You have to calculate the number of moles there. Right? එච්චරයි. ඊට වඩා අමාරු කරන්න බෑ. හරි. Then do the second one. What is the mass of glucose required to prepare 1 cubic decimeter 1 cubic decimeter of 2.5 moles per cubic decimeter glucose solution? ඔන්න තව චුට්ටක් advance කරලා පොඩ්ඩක් විතර. Yes, try. Yes, Kavinu. Doing?
Yes, miss.
හරි. දැන් හිතන්න කොහොමද පටන් ගන්න කියලා. Yes, tell me the answers. Send me the answers at least. Go, Yanul, Didula, Ovindi, Veena. I can't see. Yanul done? What's the answer?
She said 2.5 moles.
2.5 moles. Name, Ahane, what is the mass of glucose?
Oh,
Okay, I have received how many answers? Hari. Tedini says one answer. Sinadi, Nelly, Tatsara, Kavino, Tenuchi, Tejana. 1, 2, 3, 4, 5, 6. 6 of you have sent the same answer. Right? One of you has sent another answer. අපි තව විනාඩියක් දෙමු හැදුවේ නැති අයට. Just think, you are asked the mass of glucose required to prepare 1 cubic decimeter of a 2.5 moles per cubic decimeter glucose solution. No, Yanul. හරි. බලමුද එහෙනම්? Volume of your voice is lower than usual. Is it? මාව අඩුවෙන්ද ඇහෙන්නේ? ඒ මොකද? ඉන්න දැන් කොහමද? How is it now? Is it the same or different? The same. ඉන්න එක හදාගෙන ඉන්න ඕනේ නැත්තම්. Now the same. Why is that? දැන් හරිද කියන්න පුතේ? මම ඇහෙනවද? ඒ විදියම නම් Yes, how is it? Yes, Tatsara? මට ඉස්සර Tatsara ඇහෙන්නේ නැහැ. Tatsara, did you say something? Yes, could you please tell it once again? The volume is still the same. I don't know why. Low sound. මොකද කරන්නේ? this also, please. Until I just get this corrected. නැත්නම් දිගට මෙහෙම වුණොත් බෑනේ. කතා කරන්න බලන්න. මේ දැන් බෝඩ් එක හරි ගිහිල්ලා අර BY මොනවාද මයික්‍රොෆෝන් දෙකම රතු පාටට බ්ලින්ක් වෙනවා charger එකට ගහලා තියෙද්දි.
එකම රතු වෙනවා. එහෙනම් අනිත් එකයි ගලවලා ගහගන්න වෙනවා මේ මයික් එක කියන charge එක.
අනිත් එක ගැහුවා බෙල්ලේ දාන එක.
ඒක ගහලා මයික් එක පික් කරන්න ඒක එතනින් එන එක.
ඒක ගැහුවා මයික්‍රොෆෝන් 3 USB audio device නේද? මයික්‍රොෆෝන් 3 USB audio device කියන එක සිලෙක්ට් කළා. ළමයි කියනවා ඇහෙන්නේ නැහැ ඉමාව.
එතන තියෙන අනිත් ඒවා මාරු කරලා බලන්න අනිත් ඔප්ෂන් මොනවද වෙන්නේ මයික්‍රොෆෝන් එකේ?
Logitech එකයි BY එකයි.
Logitech එක දාන්න. Logitech කියන webcam එකනේ. ඒක උතන මැදලා තියෙන්නේ. ඒක අරකට වඩා ක්ලියර් වෙන්නේ.
ඒක ගහලා තමයි එදා ගුරු නිවසෙන් කම්ප්ලේන්ට් කළේ ඇහෙන්නේ නැහැ කියලා.
ඔයා ඒ කියන්නේ Logitech කියලා ගත්තොත් කැමරාව ළඟ ඔයා හිටගෙන කතා කරනවා නම් Logitech එක ළඟ තියෙන්නේ.
දැන් අරක මාරුවට එකක් ගනිද්දි අනිත් එක charge වෙන්න ගහලා තිබුණේ මම.
මෙහෙම කරන්නකෝ එහෙනම්. ඔයාගේ ෆෝන් charger එක තියෙන්නේ. කම්පියුටර් එකේ අරගේ charge වෙන වෙලා යනවා. ඔයාගේ ෆෝන් charger එකට අරක ගහන්න උතර ඉක්මනට charge වෙනවා. එතකන් දැනට අරකින් manage කරන්න.
Now teach. Now okay teach.
දැන් හරිද?
Okay, teach.
හරි. එහෙනම් මම ඉස්සෙල්ලා I will explain the first one. Second question. What is the mass of glucose required to prepare 1 cubic decimeter of a 2.5 moles per cubic decimeter glucose solution? Right? So you are supposed to take a glucose solution. Then කොතනින්ද පටන් ගන්නෙ? What is the mass of glucose required to prepare this amount of number of moles equals mass divided by the molar mass. Mass divided by the molar mass. So you are supposed to find the mass. Mass equals number of moles multiplied by the molar mass. Harida. So the number of moles you have found out as 2.5 moles. 2.5 moles. Right? Then the molar mass. Relative molecular mass should be taken in grams. That is 180 grams per mole. 180 grams per mole. Right? Mole per mole. So the mass is equal to 180 into 2.5. Again, 180 into 2 can 360. Plus 0.5 can half ne. Good 90. 360 plus 90 can 450 grams. Ne 450 grams. That's the answer. And අන්තිමදී හැමෝම වගේ answer එක එවලා තිබුණා. හරිනේ 450 grams. ආයි මාව ඇහෙන්නේ නැද්දෝ ගියොත් කියන්න. ඒ වෙලාවෙම කියන්න. හරිනේ? අයිළඟ එක කරන්න බලන්න. 3 and 4. Next two sums, do them. Okay, Tedini. And if you find any problem, once again ask me. Send a message to the chat. හරි බලමු. ඇති නේද? Work out the mass of sodium hydroxide that should be weighed to prepare 500 cubic centimeters of a 1 mole per cubic decimeter sodium hydroxide solution. Hari. The mass of sodium hydroxide. Then the relative atomic masses are not given by me, but in most of the calculations you will be given those, right? Hari. එතකොට hydrogen equals 1. කවුරුත් ඇහුවෙත් නැහැ. Oxygen equals 16. Sodium is 23. Right? The relative atomic masses will be given in the calculations. Right? Hari. The mass of sodium hydroxide that should be weighed to prepare. ආයිත් අතනින් තමයි පටන් ගන්න ඕනේ. Concentration and volume are given. So concentration equals number of moles divided by the volume. So number of moles equals concentration into volume. So concentration is given as 1 mole per cubic decimeter. Then the volume is given as 500 cubic centimeters. So you have to convert it into cubic decimeters. I taught last week. Mataka, the unit conversions. So 500 cubic centimeters means 0.5 cubic decimeters. Always substitute along with the units. Right? 0.5 cubic decimeters. So per cubic decimeter. So number of moles equals 0.5 moles. You are asked to calculate the mass of sodium hydroxide. So sodium hydroxide, what is the relative molecular mass? Yes, sodium is 23 plus oxygen 16 plus hydrogen 1, altogether 40. Right? Then you can say the number of moles equals mass divided by the molar mass. So the mass is equal to number of moles multiplied by the molar mass. Harida. So the number of moles is here the 0.5 moles. 0.5 moles. In the past say the molar mass, relative molecular mass taken in grams, that is equal to the molar mass. So 40 grams per mole, that is the mass of 1 mole of sodium hydroxide. So mole per mole, 40 grams into 0.5, again 20 grams. Neither. Did you get that? Yes? Hari. What's right? TNA. ඊට පස්සේ what are the steps to prepare the standard solution? ඊළඟ එක හැදුවද? Did you find the answer for part 1?
Excuse me, madam.
Yes, Tejan.
Can you please explain the second question again, madam? I didn't get it.
This one.
Yes, madam.
Hari. So it is given that you are asked to prepare 500 cubic centimeters of 1 mole per cubic decimeter sodium hydroxide solution. Maybe 500 cubic centimeters is the volume, right? Then 1 mole per cubic decimeter is the concentration, right? So you need to find the mass of sodium hydroxide. දැන් එහෙමනේ අපිට කියනවා මෙන්න මේ concentration එක තියෙන solution එකක් හදන්න. We need 500 cubic centimeters. But in the laboratory you are given sodium hydroxide in the pellet form. Pellet නැත්නම් මොනවාද solid form, right? Pellets ඉදිරියට පොඩි පෙති වගේ තමයි sodium hydroxide එන්නේ. I think you need to calculate the mass of sodium hydroxide that should be taken. And you can start from here. The concentration equals number of moles divided by the volume, right? එතකොට from that you can calculate the number of moles. Concentration into volume, right? So the concentration is given as 1 mole per cubic decimeter. ඊළඟට 500 cubic centimeters කියන්නේ 1000 cubic centimeters is equal to 1 cubic decimeter. හරිද මම එදා කිව්වේ 1 cubic centimeter is equal to 1 milliliter. 1 cubic decimeter is equal to 1 liter. Right? එහෙනම් cubic centimeter, 1 cubic centimeter is equal to 1 milliliter. And 500 cubic centimeters means 0.5 cubic decimeters. Harine? A step එකත් හරි. Then you get the number of moles as 0.5 moles. හරිද තේජාන්? ඉස්සෙල්ලා ගණන වගේමයි. ඊට පස්සේ you have found out the number of moles, but you are not provided with moles of sodium hydroxide in the laboratory. You have to convert it into a mass. So number of moles is equal to mass divided by the molar mass. Harida, how to find the mass? That is equal to number of moles multiplied by molar mass. Harida, on the molar mass we should know the relative molecular mass of sodium hydroxide. Harida. So this is the relative molecular mass of sodium hydroxide, that is 40. Once we take the relative molecular mass in grams, it is equal to the molar mass. Again, mass of 1 mole of sodium hydroxide. Mass equals number of moles into molar mass. Number of moles you have found out as 0.5 moles. Molar mass is 40 grams per mole. Right? Once you multiply, you get the answer as 20 grams. So in order to prepare this solution, you need to take 20 grams of sodium hydroxide. Harida? Okay?
Okay, madam. Thank you, madam.
Then do part 3.1 කරන්න. ඊට පස්සේ steps ටික මම කියලා දෙන්නම්. මේ වගේම ගානක් තියෙනවා. හදන්න බලන්න. sodium hydroxide මම අරගෙනත් තියෙනවා. Okay, Tedini. Kavina, send me the answer. හරි. ඔන්න answers 4ක් ඇවිල්ලා තියෙනවා. හරි. දැන් පුළුවන් වෙන්න ඕනේ you are asked to prepare 250 cubic centimeters of a 1 mole per cubic decimeter sodium hydroxide solution. Harry, calculate the mass of sodium hydroxide to be taken. For part 1, once again, you have used the equation C equals N over V. मैं කටපාඩම් කරන්න එපා. මේක දැන් වෙන විදිහකට දුන්නොත් you should be able to solve that sum also. හරිද පටන් ගන්න ඕනේ කොතනින්ද කියලා චුට්ටක් කල්පනා කරලා බලන්න. So the concentration equals so you need to find the number of moles name. So concentration into volume. So concentration is given as 1 mole per cubic decimeter. 1 mole per cubic decimeter into the volume is 250 cubic centimeters. That means 0.25 cubic decimeters. හරිද? දැන් මෙතන units ලිව්වේ නැත්තම් සමහර වෙලාවට ඔයගොල්ලෝ මෙතන 250 ලියන්නත් ඉඩ තියෙනවා. ඒ නිසා units දාන එක හොඳයි. වරදින්නේ නැහැ. Per cubic decimeter. එතකොට number of moles equals 0.25 moles. හරිද? 0.25 moles. ඊට පස්සේ on a sodium hydroxide the relative molecular mass is 40. අපි කලින් හෙව්වානේ 40. ඊට පස්සේ you are asked to find the mass. No, number of moles equals mass divided by molar mass. Therefore mass equals number of moles multiplied by the molar mass, right? So number of moles is 0.25 moles into molar mass is relative molecular mass taken in grams. Then it becomes grams per mole. Mole per mole. So number of mass equals 0.25 into 40. Again 2.5 into 4. That is 10 grams. On the mass of sodium hydroxide you have found out as 10 grams. ඊට පස්සේ කියනවා write down the steps of preparing the solution. Right? So I will explain that. I think in your textbook you are given the images. ලොකු image එකකුත් නැහැ ඉතින්. I will explain, then I will share video. එතකොට හරිනේ. හරි. දැන් මේක හදන්නේ කොහොමද? මෙතන හරි. So first of all you have to measure 10 grams of sodium hydroxide accurately. Measuring the mass accurately is very important. Metal 10.1 unot concentration will be totally changed. 10.1 grams unot. If it is 10.01 unot, the concentration can be changed. Therefore, you have to say measure 10.00 grams of sodium hydroxide accurately by using the chemical balance or triple beam balance, right? Nathan then 4 beam balance. By using these type of balances, you can measure the mass of sodium hydroxide accurately. That is the first step. මොකටද measure කරන්නේ? You can use a watch glass. Use a watch glass and measure this 10 grams of sodium hydroxide. කොහොමද measure කරන්නේ? First of all, you measure the mass of the watch glass. හරිද? ඊට පස්සේ අපි හිතමු you got කීයක් විතර වේද watch glass එකක්? I will say 13 grams, right? Then you add the mass of sodium hydroxide to be measured. That is 10.00 grams. Again, altogether this is here the 23 grams. If you are using the triple beam balance or the 4 beam balance, you can adjust the value to 23 grams. Then until it becomes balanced, you can add sodium hydroxide. එමයි හරියටම measure කරන්න. Right? එතකොට ඔයාලා steps ලියද්දී ඔක O level වලටත් අහලා තියෙන write the steps කියලා. එතකොට මේ measure කරන විදිය ලියන්න ඕනේ නැහැ, but you have to say measure 10.00 grams of sodium hydroxide accurately into a watch glass. 1 mark. හරිද? ඔක්කොම ටික කියලා තියෙනවා. ඊට පස්සේ then what is the volume of the solution to be prepared? That is 250 cubic centimeter. And in the laboratory there are volumetric flasks. Volumetric flask කියන එක මෙන්න මේ වගේ. Right? They are of different volumes. 100 cubic centimeters, 200 cubic, 250, 500, 1 cubic decimeter. Likewise, there are volumetric flasks of different volumes. Then මෙතන අපි select කරන්න ඕනේ, we have to select a 250 cubic centimeter volumetric flask. හරිද? You have to select a 250 cubic centimeter volumetric flask. Hard. And you have taken, and in that they have mentioned the level like this. මෙන්න මේ වගේ පොඩි mark එකක් දාලා තියෙනවා flask එකේ. 250 mark. ඊට පස්සේ you hold the watch glass with sodium hydroxide. Hold the watch glass with sodium hydroxide. Hold it like this in විනාඩියක්. Hi. මෙන්න මෙහෙම අල්ලනවා. You hold the watch glass with sodium hydroxide. තව එකක් අමතක වුණානේ. එතෙන් අපි තියාගන්නවා. You take a glass funnel also. These are the equipment needed. On ඉස්සෙල්ලම watch glass එකක් 250 cubic centimeter volumetric flask. Then you need a funnel. නැත්නම් it is difficult to transfer the substance නේ. මෙන්න මෙහෙම funnel එකක් තියෙන දානවා. ඊට පස්සේ you hold the watch glass with sodium hydroxide like this. මෙහෙම අල්ල ගන්න. Then in the laboratory there are wash bottles නේ. Wash bottles with distilled water. You are given a wash bottle. It contains distilled water. So once you squeeze the bottle, water comes out, distilled water comes out, and this is washed off. Sodium hydroxide is washed off. Make a wash වෙලා it falls into the volumetric flask. හරිද? ඊට පස්සේ nothing should be remained on the watch glass. Therefore, you have to wash the surface of the watch glass and the inner surface of the funnel into the volumetric flask. කොහොම wash කරලා දාන්න ඕනේ. හැබැයි ඔය ටික wash කරනකොට මේ mark එක exceed වෙන්නත් බෑ. හරිද? ඔය වැඩ ටික ඔක්කොම වෙනකොට this should be filled like two-third of the total volume should be filled once you wash these off everything. The watch glass, inner side of the funnel, everything is washed and transferred into the volumetric flask. Then only 2/3 of the total volume should be filled. For the volumetric flask, there is a stopper. And we have a stopper එකක් තියෙනවා. Moodiyak. Right? Then after transferring, you stopper the bottle. Name a stopper. Insert the stopper, then you have to dissolve all the sodium hydroxide. For that, we should not use a glass rod, right? If we use a glass rod, certain amount comes in contact with the glass rod also. Therefore, we should not use a glass rod. Make a dissolve කරන්නේ මෙන්න මෙහෙම නම් දැන් if this is the volumetric flask, you have to keep your thumb on the stopper and just rotate it like this. මෙන්න මෙහෙම කරලා තමයි you have to dissolve the sodium hydroxide. මේක තනිය අතින් කරන්න ඕනේ. කරන්න පුළුවන්, right? Like this. මෙහෙම keep one finger on the stopper and dissolve all the sodium hydroxide. Right? Finger එක අයින් කළොත් stopper will be fallen. Right? එහෙම තමයි dissolve කරන්න. Right? ඊට පස්සේ you can add distilled water. දැන් මේ හරියට විතර තිබුණානේ. Now remove the stopper and distilled water. දැන් තව ටික ඔක්කොම දියුණාට පස්සේ මෙන්න මේ level එකට විතර you add distilled water. Right? Okay? ඊට පස්සේ දැන් තව චුට්ටයි දාන්න තියෙන්නේ. ඒ ටික කොහොමද fill කරන්නේ? එතකොට අර මතකද grade 6 වල ඉගෙන ගත්තා. දැන් the meniscus is appeared to be like this. So you have to take it to your eye level. හරිද? අපේ ඇස් මට්ටමට ගෙනල්ලා මෙන්න මෙහෙම the lower curved point of the meniscus. මෙන්න මේකේ මේ පහළම curved point එකේ level එකට එනකම් වැඩිපුර ඉරක් යනුනානේ. පහළම curved point එකට එනකම් මොකද කරන්න ඕනේ? You have to add water, distilled water drop wise. හරිද? එක පාරට දාන්න ගියොත් ඔක exceed වෙනවාමයි. ලැබ් එකේ හදනවානේ දැන් ප්‍රැක්ටිකල් කරනවානේ. දැකලා තියනවා කරන හැටි. සමහර අය කලබල වෙනවා හෝස් ගාලා දානවා මේක. එතකොට වැඩක් නැහැ. ඊට පස්සේ සමහර අය බයට ගොඩාක් හිමින් දානවා. එහෙමත් බෑ. drop wise you have to add water up to this lower meniscus. එතකොට ඇහැ තියෙන්න ඕනේ මේ level එකේ. හරිම විදිහට නම් මෙන්න මේ level එකේ තමයි ඇහැ තියෙන්න ඕනේ. lower meniscus level එකේ you have to keep your eye. Right? You have to keep your eye at the level of the lowest meniscus, lowest curved point. Then you can add water, distilled water, drop wise. හරිද? ඔක්කොම දිය වුණාට පස්සේ ඔය වැඩේ කරන්න. Okay? Then after that මොකද වෙන්නේ? Then your solution is ready. ඊට පස්සේ you can paste a label on this. then label එකක් අලවනවා. Name of the solution, sodium hydroxide, concentration 1 mole per cubic decimeter. ඊළඟට the date of preparation. කවදාද හැදුවේ? This information should be mentioned. Volume එක ඕනේ. It is in the volumetric flask and a person who needs can measure the volume and take the required volume. But the concentration is a must. ඔන්න ඔය ටික තමයි කියන්නේ. දැන් ඔය steps ටික ඔක්කොම all these the whole method should be presented in either 3 or 4 steps. ගොඩක් අහලා තියෙන්නේ 3 steps 4 steps වලින් ලියන්න කියලා. එතකොට you should be able to summarize. අර සිංහල වල කරන්නේ summarize කරන්න. ඔක්කොම ටික කියවෙන්නත් ඕනේ. right? හරි. මම වීඩියෝ එකක් පෙන්නනවා. අපි මේකට කියනවා preparation of standard solutions කියලා. preparation of standard solutions. අපි කියන්නේ එදා ගුවා මොකද ෆෝන් නම්බර් එක වැරදිද දාලා තියෙනවා.
තියෙන මදාම නම්බර් එක.
ඒක තමයි මම දාලා ෆෝන් නම්බර් එක මගේ බෑන්කක් දෙන්නේ.
ඕකට දෙන්න ඕනේ.
ඔව්.
මොනවද?
එතකොට මේකට ඇවිල්ලා නැහැ මොකොත් ඉතින්. යාලා කියන්නේ ඔයා ෆෝන් නම්බර් එක දාලා තියෙන අනිත් එක කියලා.
ඔව් ඒක නෙන්න SMS එක.
ඉතින් අනිත් ෆෝන් නම්බර් එකෙන් යන්න තැනක් තියෙනවද බලන්න.
අපිට ඕන ගහන්න පුළුවන්
ආයෙ
නේද?
නම් ගහන්න
දෙන්න.
මේකේ නම්බර් එක දාන්න.
6
ඔව්.
අනේ ඕන සෙට් එකම කියන්න.
Surf Excel දැන් රුපියල් 540කට පමණයි.
So I mentioned the steps that you have to write, which are mentioned in your textbook. So in these videos, certain steps may be slightly different, right? That come in what happens to sodium hydroxide that come in contact with the stopper. It is inside, it is in the volumetric flask. එතකොට sodium hydroxide that comes in contact with the stopper එකයි අර අපි දෙපැත්තට මාරු කරන්නේ. එතකොට they will also get dissolved, right? They will also get dissolved, and if the droplets are remaining on the stopper, they will fall back into the solution නේද?
Okay, madam.
In this lesson, we are going to prepare a standard solution. Welcome to Science A Plus, and here is another episode of Science Experiments. Check out our channel and don't forget to subscribe to see more videos like this. First of all, let's see what is a standard solution. A solution in which the concentration is very accurately known is called a standard solution. Let's learn more about the concentration of a solution. The definition of concentration is the amount of moles of solute contained in unit volume of a solution. Let's see concentration in a form of equation. Concentration is equal to moles over volume. The unit of concentration is moles per cubic decimeter. Concentration is used to express the composition of a homogeneous mixture or else a solution. So, for the calculation of concentration, we need values of number of moles of the solute and the volume of the solution. So, why do we need the composition of a solution to be accurate? Well, the accurate composition of a solution is necessary to get accurate results from laboratory experiments and for the preparation of industrial solutions. So this knowledge is going to be useful in a vast majority of fields. So let's make a standard solution. In this practical, we are going to prepare a solution of sodium chloride with a specified concentration. And the concentration of the solution is 1 mole per cubic decimeter. The volume of the solution is going to be 250 cubic centimeters. In our process, the first step is to calculate the weight of sodium chloride. Here we have shown the calculation. We will need 14.625 grams of sodium chloride to prepare this specific standard solution. After this calculation, we have to use a chemical balance to accurately measure the weight of sodium chloride. Here is a complete list of equipments that we need to carry out this experiment. We need volumetric flask, wash bottle, watch glass, chemical balance, funnel, and the chemical sodium chloride. Let's see the steps of preparation of the standard solution of sodium chloride. Here you can see we have measured the required amount of sodium chloride. We used a chemical balance to accurately measure this amount. Here we have a funnel, a wash bottle, and a volumetric flask. This volumetric flask is marked as 250 milliliters. So, this 250 milliliters is equivalent to 250 cubic centimeters. The first step is to remove the lid of the volumetric flask, and then we put a clean funnel into the volumetric flask. Here we have sodium chloride in our watch glass. We use the wash bottle to wash out the sodium chloride into the funnel. Through the funnel, it flows into the volumetric flask. Here you can see we are thoroughly washing the watch glass so that sodium chloride does not remain in the watch glass. The next step is to thoroughly wash the funnel so that sodium chloride in the funnel is washed into the volumetric flask. These steps ensure that all the weighed sodium chloride enters into the volumetric flask. Now we remove the funnel from the volumetric flask. Now the volumetric flask is filled roughly 2/3 of its volume. It is easy to mix the solution when the volumetric flask is partially filled. We shake the volumetric flask so that the sodium chloride solution mixes well. Now we remove the lid of the volumetric flask and put the funnel so that we can fill the solution with water until we reach the mark on the volumetric flask. When the water level reaches the mark of the volumetric flask, we need to be careful regarding the water meniscus. Here is the mark of the volumetric flask. When watching for the water meniscus, it should be at our eye level. Here we have to remember that the water meniscus has a curved shape. The lowest curved point of the water meniscus need to be aligned with the mark of the volumetric flask to get the volume precisely. This is essential when making a standard solution. To get the volume correctly, we add water drop by drop from the wash bottle. After this, we remove the funnel and close the volumetric flask with its lid. Then we use this technique to correctly mix the solution. Here we have to mix it 2-3 times. Keep in mind that we have to reduce the contact with the bulb of the volumetric flask as much as possible. So, when mixing, we do it as quickly as possible and touch the bulb of the volumetric flask with our fingertips to minimize the contact. That is because heat from our palm can be transferred into the standard solution, and this can lead to chemical reactions. So we have made the standard solution, and the final step is to label it. The label should contain the name of the solution, the concentration, its volume, and the date it is prepared. Let's revise what we need to consider when preparing a standard solution. Just like any other chemical experiment, we need clean instruments, so cleanliness is very important. And for accurate results, we need accurate amounts of solutes. So weighing the solute accurately is also important. When transferring substances, sticking is very common with chemicals. So washing well when transferring chemicals from watch glass to the funnel and then into the flask is also important. When mixing the solution, do not touch the bulb of the flask and use the correct technique for mixing, just like we showed in the video. For a standard solution, the volume need to be accurate. So, carefully assessing the final volume is also important. Observing the volume mark of the flask should be done at eye level. And the standard solution need to be pure. So, prevention of entry of impurities into the solution is also important. That brings us to the end of this video. Check out these suggested videos and
Hi. Now you can write the steps, right? You can write the steps. And you should be able to write the steps. Preparation of standard solutions. Preparation of standard solutions. These are volumetric flasks, wash bottle, watch glass, funnel. These are the things needed. Right now I have explained the method and showed you a video also. ලියන්න බලන්න දැන් steps ටික හරියට තනින්. ඊට පස්සේ I will ask.
වොයිස් එක හැවුවාද ඒ විදිහට ලොග් වෙලා බලුවද වෙබ්සයිට් එකට. ඔන්න විසඳුමක් විදිහට තමයි 520 නම්බර් එකෙන් ලොග් වෙලා බලන්න කියලා කිව්වේ. ඒකට තමයි කියන්නේ අපි පේමන්ට් එකක් කරපු එකක් නෙමෙයි මිස් වෙබ්සයිට් එකෙන් පේමන්ට් එක කරලා තියෙන්නේ. එතකොට මිස් අතෙන් ක්ලික් වෙලා තියෙන්නේ 520 නම්බර් එක. ඒතකොට වෙන නම්බර්ස් වලින් ලොග් වෙලා බලුවට මිස් කොහොමද ක්ලාස් එක පෙන්නන්නේ නැහැනේ. එතකොට පේමන්ට් එක කරපු නම්බර් එකෙන්ම ලොග් වෙන්න ඕනේ. මිස්ට 520න් ලොග් වෙන එකේ ගැටලුවක් තියෙනවා නම් මෙසේජ් එකක් දාන්න ඒක චේන්ජ් කරලා දෙන්න. එහෙම නැත්නම් මිස් ලොග් වෙලා බලන්න. මේ ඔයා පස්සේ නම්බර් එකෙන් තමයි පේමන්ට් එක කරලා තියෙන්නේ. වෙබ්සයිට් එකට ලොග් වෙලා බලලා තියෙන 699 නම්බර් එක. දැන් 599 නම්බර් 520 නම්බර් එකෙන් වෙබ්සයිට් එකට ලොග් වෙලා බලන්න.
520 නම්බර් එකෙන් ලොග් වෙච්ච නිසා තමයි කිව්වේ. එතකොට කියනවා මොකුත් ඩීටේල්ස් ඊමේල් ඒවා දාලා නැහැ කියලා. අනිත් නම්බර් එකෙන් ගියාම ඒත් බෑ කියනවා. මට OTP එක නම්බර්ස් දෙකටම එනවා. එක OTPs. මොනවද ඉතින් පන්තිය නතර කරන්න තමයි වෙන්නේ. පන්සිවිස්ස නම්බර් එකෙන් ලොග් වෙච්ච නිසා තමයි කිව්වේ. එතකොට කියනවා මොකුත් ඩීටේල්ස් ඊමේල් ඒවා දාලා නැහැ කියලා. අනිත් නම්බර් එකෙන් ගියාම ඒත් බෑ කියනවා. මට OTP එක නම්බර්ස් දෙකටම එනවා. එක OTPs. මොනවද ඉතින් පන්තිය නතර කරන්න තමයි වෙන්නේ.
මිස් ඊමේල්ස් එහෙම දාන්න කියලා ඉන්නේ මිස් වෙබ්සයිට් එකට ලොග් වෙලා ඉන්නේ නිසා. එතන මිස් අතින් හෝම් කියන බටන් එක ක්ලික් වෙලා ඇති. මිස් එතන උඩ තියෙනවනේ එලි තුනක් අන්න ඒක ක්ලික් කරලා ක්ලාසස් කියන එකට යනකොට එතකොට go to class කියලා එනවා. එහෙම කිව්වොත් විතර මට ස්ක්‍රීන්ෂොට් එකක් ගන්න දෙන්න.
Yes, you have to write the steps. Kobalan mehema liwada kiyala on and then disappear vela. Yes. එතකොට කියන්න ඕනේ දැන් අපිට ආවේ කියලා mass එක 10 grams. Measure 10.00 grams of sodium hydroxide accurately onto a watch glass using a 4-beam balance or the chemical balance. Harida, Livada, that is the first step. Weigh or measure 10.00 grams of sodium hydroxide accurately onto a watch glass using a chemical balance or the 4-beam balance. Hi. Ilangata, take a clean 250 cubic centimeter volumetric flask. Eking navattන්න එපා නේද? මොකද steps 3කින් ලියන්න කිව්වොත් ඒකට තව add කරන්න වෙනවා. Take a 250 cubic centimeter volumetric flask and transfer the weighed sodium hydroxide completely through a funnel. I can take a clean 250 cubic centimeter volumetric flask and transfer all the sodium hydroxide through a funnel using the wash bottle. Harida? Then, third step, wash the surface of the watch glass and the inner surface of the funnel and transfer the washings into the flask until the total volume is about 2/3 of the volumetric flask. Right, wash the inner side of the watch glass and inner surface of the funnel and transfer that water into the volumetric flask until the total volume is about 2/3 of the total volume of the volumetric flask. Right? Shake the flask so that all the sodium hydroxide dissolves well and add water carefully, keeping the eye at the level of the volume mark of the flask. Right, until the total volume becomes 250 cubic centimeters. මේකත් ඇඳලා පෙන්නන්න පුළුවන්. The eye level is at the lower curved point of the meniscus. මේක ඇඳලා පෙන්නන්න. Stop the flask and mix again. Then you have to paste a label. So based on the question, you can summarize these steps. Now steps ටික summarize කරන්න පුළුවන් වෙන්න ඕනේ based on the number of steps that you are asked. මෙතන නම් මම steps ගානක් කියලා නැහැ. හරිද ලිව්වද මේ විදිහට? Did you write like that? හරි. Okay ඉවර කරලා 2-minute break එකක් අරගෙන එන්න. ඉවර කරලා හැබැයි now it is 6:21. You have to finish by we will start once again by 6:25. හරිද? පුංචි break එකක් අරගෙන ඉක්මනින් එන්න. ඉවර කරලා හා දැන් ඔයාට මං කියලා තියෙනවා මෙතන කෑ ගහන්න එපා කියලා. හරි දැන් ඇති නේද? So දැන් එන්න ආපහු turn on the videos. අවනේ ගිහිල්ලා. So what are the factors to be considered when we are preparing a standard solution? Hari. Cleanliness of all the equipment used, right? Cleanliness of the equipment used, right? If there were certain other contaminations from other chemical substances, the concentration will be totally changed. And a new chemical substance can also be formed. කලින් හරියට ක්ලීන් කරලා තිබුණ නැත්නම් ඇසිඩ් එකක් එහෙම ඉතුරු වෙලා තිබුණා නන්නේ. Weighing the solute accurately. ඊළඟට washing well and transferring substance, sticking onto the watch glass and the funnel into the flask. You have to wash everything into the flask. Use the correct technique for mixing. I told you the correct technique. It was not shown even in the video. Adjusting the final volume accurately. You have to keep the lower meniscus at your eye level and top up, drop twice. Prevention of entry of impurities into the solution. That is why we are not inserting even a glass rod to dissolve the substances. Hari. What is the mass of potassium carbonate required to prepare 500 cubic centimeters of 1.5 moles per cubic decimeter potassium carbonate solution? Potassium carbonate කියන්නේ මොකක්ද කියලා හොයාගන්න ඕනේ. Last week I just reminded how to write the chemical formula නේද? In the paper class session. හරි. බලන්න හදන්න. Within 2 minutes. Yes, Yanul, have you come back? And answer Sevan Hamom. What is the mass? හරියටම හදනවා කියලා හිතාගෙන හදන්න. Okay, Tarundi. Done. Ankian, what is the answer, Sinadi? Finished? Didula has sent an answer. Balamu. Sheneli has sent another answer. I don't know the answer yet. We'll see. Anugi, Kavindra has sent a similar answer to another one. Sinadi, Hari. Aikaja the answers tikak tiyana. Tejan, Nelly, Kavindra, Vidula. They have got similar answers. Yanul. Yanul decimal point එක මිස් වෙලා මම හිතන්නේ. බලමුද? හරි. තත්සර Shall we check? So මට අනිත් අය එවනවා මම මේ බලන් ඉන්නේ. I even didn't mention the answer sent by the others. I want all of you to send an answer. think Teddy has sent another answer. Hari. Okay, Elisha. Hari. Malum, what is the mass of potassium carbonate required to prepare 500 cubic centimeter of a 1.5 moles per cubic decimeter potassium carbonate solution? Hari. So what is the formula of potassium carbonate? What's the formula of potassium carbonate? Here, Mokadda. Yes?
K2CO3. K2CO3.
K2CO3. K2CO3. So potassium, the valence is 1. Carbonate is CO3 2 minus. Therefore the valence is 2. Once you exchange the valences, this becomes K2. This one belongs to the carbonate radical. K2CO3. Right? Hari. ඊට පස්සේ මොකද කරන්නේ? You have to find the relative molecular mass of potassium carbonate. Relative molecular mass of potassium carbonate. Potassium is given as 39. 39 into 2 plus carbon is 12 plus oxygen 16 into 3. So this is 78 plus 12 plus 48. Ne? එතකොට 48 plus 12 කියන්නේ 60. 138. Nick? 138. That is the relative molecular mass. Then you have to convert this into the molar mass. Hari. අපි දැන් පටන් ගමුකෝ ආයතනෙ. The volume is given, concentration is given. So C equals N over V. So number of moles equals concentration into volume. Concentration is given as 1.5 moles per cubic decimeter, right? Then the volume is 500 cubic centimeters scale again is 0.5 cubic decimeters, right? 0.5 cubic decimeters. So here the yes, so 0.75, ne? 0.75 moles. Right, that is the number of moles. Then you are asked what is the mass, right? You are asked about the mass of potassium carbonate needed. Therefore, you substitute for the equation number of moles equals mass divided by the molar mass. Then me පස්වෙනි ගාන විතරනේ හදන්නේ. So the mass is equal to number of moles multiplied by the molar mass. Number of moles is 0.75 moles. Then the molar mass, relative molecular mass should be taken in grams. 138 grams per mole. එතකොට මෙතන 0.75 කියන්නේ 3 over 4 වගේනේ. එතකොට මේක ලියන්න පුළුවන් mole per mole 138. එන්න මෙහෙමනේ grams. එම්බෙදනවාද? හරියට බෙදෙන්නේ නැහනේ. බලන්න හරියට. 34.5. $103.5 grams, is it? 103.5 grams. හරි නේද? Alright, so what is the mass of potassium carbonate required? That is 103.5 grams. මම හිතන්නේ majority of you have got the answer. දැන් පුළුවන් නේද? ඔය ගණන් තමයි එන්නේ. Right? You will get this type of calculations for the question paper. මේක තමයි මේ expressing the composition වල තියෙන අමාරුම කියන්න බෑ. ඒ methods වලින් complex method එක ඒක. ඒකට complex method එකත් එච්චර අමාරු නෑනේ. නේ? බිස්කට් එක අරන් යන්න. නංග බිස්කට් එක අරන් යන්න. බිස්කට් එක අරන් යන්න. හරි. තා මොනවාද අහන්න තියෙන්නේ? තා ප්‍රශ්න තියනවාද? තව ගානක් තියෙනවා. To 500 cubic centimeters of volumetric flask, 9 grams of glucose was transferred and distilled water was added until the total volume of the solution was 500 cubic centimeters. What is the concentration of the solution? ඔන්න ටිකක් වෙනස් විදියට ආවා. දැන් අහනවා concentration එක. So you will be given the relative atomic masses, right? Hydrogen is equal to 1, carbon is 12, ඊළඟට oxygen is 16. ටික දීලා තියෙනවා. Now find the number of moles. Now what is the concentration of the solution? Find it out. එවන වෙනස් method එක. හිතන්න. Harida, did you find an answer? Didula says, yes, Didula has sent an answer. Tedini, Tenuchi, Tatsara. Tenuji, just check it once again. Answer balana. Tejan. As Anugi, evan balana answer. Kavinu.
1
Srinadi has sent another answer. Mary. Koi Anul? Tavindra. What is it, Veena? Um, Kavino, I need an answer. Kavindra has sent. Anugi, did you send? Okay. අනුගේ ආයි බලන්න මීනා ආයි බලන්න චුට්ටක් මට තාම එවෙ නැති කීප දෙනෙක් ඉන්න අයවන්නකෝ බලන්න මට I want to see whether you have got the method or not. Okay, Kavino. Hari. එන අපි බලමු. Right. Now මෙතන you are given the mass of sodium, mass of glucose as well as the volume of the solution. So the place where you need to start is different, right? පටන් ගන්න ඕනේ තන වෙනස්. දැන් මොකද කරන්නේ? 9 grams of glucose. And we can start from here. Number of moles equals mass divided by molar mass. නේද? හරි. එතකොට glucose නේ අරන් තියෙන්නේ. That is C6H12O6. අපි ඉස්සෙල්ලත් හෙව්වා. It is 12 into 6 plus 1 into 12 plus 16 into 6. So that is altogether 180 නේද? That is the relative molecular mass of glucose. ඊට පස්සේ the number of moles equals the mass of glucose taken is 9 grams, right, divided by the molar mass, relative molecular mass taken in grams. That is 180 grams per mole, right? Grams. එතකොට 1 over 20 නේ? 1 over 20. So number of moles equals 0.05 moles. Mean per moles becomes moles. 0.05 moles. Harine? That is the number of moles. ඊට පස්සේ you are supposed to calculate the concentration. Though you know the concentration is given as C equals N over V. හරිද? එතකොට number of moles is 0.05 moles. Then the volume is here 500 cubic centimeters කියන්නේ 0.5 cubic decimeters. 0.5 cubic decimeters. Right? එතකොට මෙතන if you multiply this by 10, that is 5. In here this is 0.5. එතකොට 0.5 divided by 5 කියන්නේ 0.1 mole per cubic decimeter. That is the concentration. ඉස්සෙල්ලා අපි මෙතනින් පටන් අරන් මේ පැත්තට හැදුවා. Then we started from the number of moles and then calculated the concentration. හරිද සිනදී? Okay? Is the method clear for you? 0.1 moles per cubic decimeter. හරි මට ඇවිල්ලා තියෙන answers කීප දෙනෙක්ගේ විතරයි වැරදිලා තියෙන්නේ.
Miss, could you explain that again, please?
හරි. දැන් මෙතන molar mass හොයන හැටි හරි නේද? relative molecular mass එක හරිනේ. නේද? කවුද යනුද? Huh? Finding the
Yes, miss.
relative molecular mass is okay. හරි මෙතන ඉඳන් මම ආයි හදලා පෙන්නන්නම්. Right. එතකොට you are given මොනවද දීලා තියෙන data කියලා බලන්න. You are given the volume as well as the mass of glucose. Right. So since you are given the mass of glucose, you can find the number of moles of glucose. Right. You can find the number of moles of glucose. Right. There you can say number of moles equals mass divided by the molar mass. Right. The mass of glucose is given as 9 grams. Right. Then the molar mass, you have found that the relative molecular mass is 180. And now once you take it in grams, it is the molar mass. That is 180 grams per mole. 180 grams per mole. එතකොට grams එතකොට 9 into 20 නේ 1 over 20 moles කියලා නෙන්නේ 1 over 20 moles, right? So that is 0.05 moles. The number of moles of glucose that you have taken is 0.05 moles. හරිනේ? ඊට පස්සේ අපෙන් අහන්නේ what is the concentration of the solution? You know the volume and the number of moles now. So the concentration is equal to the number of moles divided by the volume. Right? එතකොට number of moles is 0.05. Actually moles තියෙනවා glucose. And the volume of the solution that you are going to prepare is 500 cubic centimeters. So it is 0.5 cubic decimeters. We need to convert it into cubic decimeters. එතකොට මේක බෙදා ගන්න තියෙන්නේ. මම කලේ I can just multiply both sides by 10. දෙපැත්තටම එකම දේ කළාම වෙනසක් නැහැනේ. Right? So it is 0.5 moles per cubic decimeter divided by 5. Right? So it is equal to 0.1 mole per cubic decimeter. Then හරිද 0.1 mole per cubic decimeter. හරිද අනුල්?
Yes, miss.
හරි. එතකොට ඔයගොල්ලෝ මේ ගණන් හදලාම ප්‍රැක්ටිස් වෙන්න. Right? You can do these calculations once again. මේ ටික මොනවත් කමක් නැහැ. ආයෙත් සැරයක් හදන්න after covering the answer. Answer එක පෙන්නගෙන ඉන්න නැතුව just cover it with a rough sheet of paper and do the calculation once again. හරිද? චරයිද තව තියනවාද? තව එකක් දීලා තියෙනවා. ඉච්චරනේ ගණන්. Oh, it was a separation techniques. Do this one, the last calculation.
Madam, can you please give the atomic masses?
What is it, Tejan? Relative atomic masses there. මතක වෙලා දෙන්න. Magnesium is 24. Chlorine is 35.5. 35.5. It is said that all the planets are visible these days. I just went out to see, but I think nothing can be seen. The sky may be cloudy. So what is the formula of magnesium chloride? ඒක දැනගන්න ඕනේ ඉස්සෙල්ලාම.
MgCl2.
Yes, MgCl2. Honey, I have received one. Yes, about 7 answers are received. Out of them, 4 are the same. Hari, shall I do then? Hari, balam. Then I think. So you are asked what is the mass of magnesium chloride required to prepare 500 cubic centimeters of a 0.5 moles per cubic decimeter magnesium chloride solution. And then once again the concentration and volume are given like in the first few calculations. From the concentration equation, C equals N over V. So the number of moles is equal to concentration multiplied by the volume. Right? So the concentration is given as 0.5 moles per cubic decimeter. Then the volume is given as 500 cubic centimeters, 0.5 cubic decimeters. Right? Hari. And the 0.5 into 0.5 and 0.25 per cubic decimeter. So the answer is given in moles. Magnesium chloride, the formula. The first thing is that everything will go wrong if you write the formula wrong. MgCl2. Right? Then how to find the relative molecular mass. Magnesium is 24 plus chlorine is 35.5. Right? That is 71 plus 24. That is 95. 95. Hari. The number of moles equals mass divided by the molar mass. What is the mass of magnesium chloride needed? So the mass equals number of moles multiplied by the molar mass. Number of moles is equal to 0.25 moles. The molar mass is 95 grams per mole. 95 grams per mole. Mole per mole. 95 divided by 4 0.25 can 1 over 4 So 95 divided by 4 kyanne 23.75 grams, right? 23.75 grams. So බලන්න ගොඩක් අය වෙලා තියෙනවා. ඔය ඉන්නේ මොකද උනේ බලන්න. 23.75. තරුන්දි ඊළඟට සිනදි චුට්ටක් වැරදිලා. තෙනුජි 24 වෙලා. දැන් පුළුවන්ද? Still, do you have any problem related to this? Then how many calculations did we do? මම මෙතන දාලා තියෙන number එක මන්ද 6th. I think more than 6. නැද්ද? Only 6? Oh, හරි. එහෙනම් do those 6 calculations once again. හරිද? ආයෙත් සැරයක් කරන්න. අන්න තව ගණන් ටිකක් දෙන්නත් පුළුවන්. බලමු ඊළඟට මොනවාද පොඩි දේවල් ටිකක් කියන්න තියෙන්නේ. The concentration of a solution can be lowered by adding more solvent to it. Decreasing the concentration by adding more solvent is known as dilution. දැන් ඔයගොල්ලෝ ගෙදරදීත් ඔය වැඩේ කරනවා. When you are preparing a drink out of cordial, cordial is concentrated. You take one part of cordial and put 5 parts of water according to the instructions. Then you are diluting. Solvent is water there. Then when you bring the disinfectants like Lysol, phenol, likewise they are also to be diluted before the usage. ඒක තියෙන විදිහටම බෝතලෙන් හලන්නේ නැහැ. කියවලා බලන්න instructions, right? You have to take one part of it and add another 10 parts of water. 10 part කියලා කියන්නේ if you are taking a particular cup, once you take 1 cup of Lysol, you have to add another 10 cups of water in order to dilute it. And you are making diluted solutions even at home. හරිනේ? Dilution by adding the solvent. Most of the acids in the laboratory are stored. Laboratory stores are concentrated acids. අර bottles වලින් දුම් දානවා acid bottles වලින්. හරිද? lab එකේ තියෙන concentrated acids. Mostly the acid solutions prepared by diluting those concentrated acids are used for the laboratory experiments. ඔයගොල්ලන්ට දෙන්නේ diluted acids, right? අපි ගිය සතියේ කිව්වා කොහොමද how to dilute an acid කියලා නේද? කොහොමද කරන්න කිව්වේ? Add water into acid or acid into water. Yes.
Acid into what?
Acid into water. You have to add the acid gradually into water because it is an exothermic reaction. Right? So if you add water at once, it will explode because of the large amount of heat energy generated. But once you are adding the acid dropwise into water, it will gradually be diluted. Right? Rather than at once. As a safety measure, when diluting concentrated solutions, always the acid should be added to water. It is because the dilution of concentrated acids is highly exothermic and may be dangerous. That is the reason. හරි. ඊළඟට separation of components තමයි තියෙන අලුත් topic එක. මම ඒ වෙනුවට තව ගානක් දෙන්නම් හදන්න. Right? The rest of the time. Yeah, moving on to the whiteboard. You can take a sheet of paper and do it. Is there anyone who is not joining the paper class session? Come on in and just place your hand. If I discuss this, man, put break before I start the paper class. And if I discuss this in the paper class session, is it okay? Is there anyone who is not joining? Not there. Hari, okay, Amol. Tejan, Hari. I don't know, both of you have sent the same answer. In some Hari Atikela Hitama. Yanul and Tejan have sent the same answer. Tatsara has got the same answer for the first one. Alright, Vidula has also said the same answer. Tarun, it is slightly different. Shenali has got the same answer. Anugi the same answer. Come on, Anita. Send me the answers. Don't worry if it goes wrong. දහසරයක් හදලා වැරදුනත් කමක් නෑ ආයෙ ඉගෙන ගන්න පුළුවන්. Right? For the second one, Hari. I will put the question. I can to send the questions to the WhatsApp කියලා. Then those who have finished, you can leave and join at 7:30. Right? So in the paper class, I will discuss the answers. Hari, Tedini, similar answer. Okay then. You can just leave and join. Have a small break and join at 7:30, sharp at 7:30. So I will discuss the answers there.